robot in a substation that does the visual inspection. You also have all your offline tests and information. So you have all that information coming together into a computer system using algorithms to indicate the state of that transformer. So you've got your asset, and then you've got your computer system and algorithm to indicate what is the state of your transformer, and also for the operator to make decision whether the transformer must be switched off or not, should you be having severe alarms coming from that transformer. So you've got enough information that is indicative of, that is actually giving information for the operator on the other hand to make a decision whether that transformer should be in service or not. Over and above that, not only are you giving that information to the system operator, you are giving that information to an engineer like myself. So that information comes to my computer, and no matter where I am in the world, I can actually log in and see which of the transformers are giving a problem. So, and this is an example just for a transformer where you are using AI application, but you can actually, this system is designed for the generators as well. There's condition monitoring system for the generators within Eskom, and so is every other equipment. So the plan is to roll it out on every other equipment within the network, within the power system. So every equipment that exists, including your current transformers, your measuring devices, generators I've already mentioned, even at the distribution end, which will give you information about the energy usage from the customers. Another example to the right is that of a robot. Basically, you are using a drone to inspect the lines. And in that drone, you actually have intelligence to gather the condition. You understand what is the normal line, and you can do fault location. You can do a fault identification. You can also give that information into the power systems to actually indicate the condition of that line. And then with all that information, because remember we said AI, you're gathering information, you're using history and current situation, you keep updating the kind of decision that needs to be made, given the condition, given the status of the plant, given the external factors like the weather condition. You get all that information, and then you are sending it back to the system operator, to the engineer to say, we've got severe weather conditions. Maybe this line should be switched out because it is our main corridor, but if we were to lose it in service, we're going to have more problems. We've got a problem. This line is actually arcing. We've got a problem there, but that line hasn't gone off. Now, how can you repair it? Take it out quickly, do some, or you can even do live line work on that same line. But you've got enough information to determine what is the next step and the quickest step to restore system stability before you've got more catastrophic failures within the network. So this is really very few of the examples that I had picked up to just indicate how you can apply AI in power systems, and some of these actually have already been implemented. Others are on the rollout. Like on transformers, we are rolling out what you call integrated condition monitoring system, because currently all our condition monitoring systems are either we are monitoring bushing, we are checking the PD, or we are doing, which is what is mainly our condition monitoring system that's in service, which is the DGA system. So all of that, including offline tests, we're going to integrate those and then start sending such signal that is an integrated signal to the system operators and the engineers that would need to make decision on what to do with the plant eventually. The next slide. I think that's probably the last one. So yes, we have quite a number of challenges that the power industry is experiencing. And I think from our side, I've started with aging fleet because that's the biggest one from generation to distribution. We've got more aging fleet effect. In renewable energy integration, it's something that as it is coming in, is actually threatening the stability of the system, depending on how you integrate renewable energy within the power system. Cybersecurity, without any doubt, is one of the major ones, as well as demand variation. But there's many other challenges, and how you rank them depends on where in the world you are, and also how is your power system, or rather power network, behaving. So AI application is a solution to alleviate these pressures, including skill shortages. And this can actually offer timer solution. It makes you, like the decision to either take the plant out or to save the plant even quicker. It also helps in, to better respond to the current network challenges. And this could be, that response could be coming from operators, from engineers, but also from customers, because the customer can actually assist in managing these current challenges. And also your power security and reliability can improve vastly by use of AI within the power system. I think that's all I had actually prepared for today. I wasn't sure whether I should be dwelling more on transformers before the talk or generally on power systems, but I hope what was shared is something that is valuable. Thank you, Tina. I think I'll hand over to you as you put to the next slide that has nothing else.
Thank you so much, Kaya. I think we learned a lot from your speech. I really agree with you that AI could help with predictive maintenance. I think this is also quite a big issue here in Taiwan because we have a lot of assets. They're facing deterioration, and I think AI could help to do a more proper and integrated maintenance for the important power facilities. And also energy demand forecasting, as you said, we're also really think that this is the next big issue, because if you can predict the renewable energy and also the demand more accurately, then it's going to benefit the power dispatching and maneuver. And then the fall detection, as you said, and customer engagement, I think this is quite a good point, because you can provide personalized insights, recommendations, and that's really wonderful point of view. And thank you so much. And we already collect some questions for discussion, and let me share with you. Okay. Here are some questions from the audience. Who has the first questions for the speaker?
Oh, me, teacher.
Can you explain your question?
Okay. My question is, how can AI technologies benefit Transformers diagnostic?
I think, Kaya, do you have some your insight?
Yes. So so in transformer diagnostics, firstly, I think that we are still advancing as engineers in diagnosing, transformers generally. But the condition monitoring that I had indicated has proven to be one element or one part of AI technologies, where if you have all this information, you can actually save your transformer from catastrophic failures. And that's one of the biggest advantages, is actually to prevent failures before they occur. That's saving the asset and also saving the downtime for that transformer, because you would have, instead of having a severe failure that either that transformer is not going to come back to service, or you're going to have to now have major repairs on it, you might actually save that time by, now while you caught it while it was still developing, you actually have a better chance of saving it from failure. So it has actually helped in terms of condition monitoring and ensuring that you are looking at the transformer holistically and also acting on time. I hope that actually helps.
Thank you so much. Okay. Who has the second question?
Me.
Okay.
Okay. I would like to know what are the major difference between the areas of AI applications for transmission systems and distribution systems.
Thank you so much.
Right. So when you look at the systems themselves, it actually depends, because firstly, the only difference in it's size wise and who the customer is at the end. So for instance, your AR applications for distribution systems would be more customer demand focused, because you want that feedback from the customer. And so that would be your priority, for instance. It's also in terms of prioritizing which application you would put. So that one would be more or rather applicable to a distribution system person. And then while everything else, as far as transformers are concerned, for instance, all the applications that you would have on AI, how you apply it will be a matter of economic factors. So, for instance, when we look at transformer condition monitoring systems, online condition monitoring systems, some suppliers would argue, or rather some end users would argue, that I would not want to put such an expensive system on a transformer that cost about a third of the other one, which is, for instance, I'm just comparing a transmission and a distribution transformer. So you would then be looking at the economics of it instead of the actual application, because application would still be valid for any of those, but how you implement it is now where there is more of the difference.
Thank you so much. I think I learned a lot from your point of view. Yes, I think the implementation really matters when it comes to different system structure. For example, maybe like the voltage level and the frequency response requirements, all these are different. So I mean, like AI technology is actually the same, but the way it is going to be implemented will be adjusted, and maybe the hyper parameter will also need to be adjusted, I think. Yeah.
Yes, definitely.
Okay, so let's move to the next question.
Okay, so my question is, what skills do you recommend the students to establish in order to adapt to the AI tools in power systems?
Thank you.
This is a very important question, and I wish every student would start incorporating computer studies, IT, and more IT. Even power system engineers should, adopt the skill. IT, we need more of it, and not only from the point of view that there's going to be nice application, robotics, and all this, but also from this power system security point of view, because you also need to safeguard the security of the power system against cyber attacks. So you want a power systems engineer to be able to understand the power system, but also from the IT point of view, and also be able to protect it. So more IT and IT for every engineer and anybody else that's interested in this.
Yes.
Yes.
I totally agree with you. Because in our this event, we have a lot of students, but I think their background is electrical engineering mostly, and we face a challenge that we really need to have the programming ability in order to use these AI tools. For example, like Python or like R or some
Yes.
tools for big data analysis as well. So there are just a lot of new IT knowledge that we need to build up.
Definitely. I
Yeah.
agree. I also need more of that from my side.
That means we need to keep learning and learning and learning. Yeah.
Continuously.
Yes. Okay, and so let's move to the last question.
Okay. I would like to ask, are there disadvantages of AI methods that we should be aware of while using them to solve power system problems?
Thank you so much.
Yes, there's actually lots, and I think I have mentioned cybersecurity. It's the biggest
Yeah.
one. Yes, the cybersecurity is the big, and you have to ensure that that doesn't happen. And it's actually one of the biggest hindrances to implementation of this AI application, because you are trying to convince people that have been safeguarding those power system and think it's robust and nobody else can get into it, and then you are just opening it up. So you need to ensure that you've got enough skill to safeguard it against that. So cybersecurity is the biggest one of them all, and that is something that power system engineers should be aware of. But also, just to add to that, as you are implementing these artificial intelligence applications, you need to be aware of the fact that initially you're gonna do a lot of debugging. Don't try to debug online, because you are going to give incorrect information about the status of the power system, and that could have the reverse effect on the power system. I have seen it where we are transitioning on how we gather information and do reporting, that when I do reverse engineering, I'm like, it just does not make sense. But I realized that we need to go back to, get the very first equations correct, or even worse, how you gather information, the accuracy of your sensors, everything that you are getting, that raw data. That's where it all begins. Ensure that you are actually getting that raw data correct before you can make decisions based on the outcome, which is based on incorrect information in the first place.
Yeah.
So that's
Exactly.
that for now.
Yeah, I agree with you totally. Because although there are a lot of AI methodologies, we still need to be careful about the security and also the accuracy of the data. Otherwise, it's like garbage in and garbage out. So we need to be like consider more factors that probably will affect the accuracy of the AI decisions. Yes. Okay. Thank you. And that's because it's going to the end of our webinar. And let's welcome Kathleen Lozano from Region 9 from WIP. So let's welcome Kathleen to give us some closing remark.
Thank you, Tina. I am really pleasure to be here. Thank you for your invitation. Thank you also to Kaya for your presentation. As I said before, always it's a pleasure to me participate of this kind of events In this case, we can talk about how the artificial intelligence can be incorporated to the power system, what are the key challenges and the power system in the power system, and how the AI contribute to these challenges. Also, we can see some examples of AI applications in the power system, and it's important to talk about it because the AI are a trend topic at this time, and it's a reality that we need to incorporate the new technologies to the traditional systems. It's really interesting see how we can incorporate the AI in different tasks in the power systems. And thank you so much. Was a great presentation. Also, I want to remember that in Women in Power, we are looking for foster a more diverse leadership by supporting the career advancement, networking, and education of women in the energy industry. That's why we want to highlight the work that made our women engineers into the industry. It's really important to see all the contributions of women in the area. So the invitation to all of you is to keep attending to all the events that Women in Power offers, to be attentive to all the activities and initiatives. Uh, I think that Tina was an amazing representation. She done a lot of things, and thank you so much, Tina, again. And thank you so much to all of you for the participation today in this webinar. Thank
Thank
you.
you. Thank you, Kathleen. And thank you, Kaya, again for your generous sharing about what you have seen and learned from Power System and how to utilize AI technology. And also appreciate all the audience today to participate this event. And our mission is to foster the professional skills, education, networking, mentorship, leadership, innovation, and entrepreneurship for women in power and energy sector in Taiwan. But we also welcome males to join us as well. And that's make this a great platform to share experience and to expand to the global network. And this is how to join Women in Power. First, you have to go to IEEE and to become a member, and then you can register at Power and Energy Society, and then you can join Women in Power, and this is for free. So there are a lot of resources and connections and learning opportunities in this community. I highly recommend it, and I think by learning from experienced experts and global experts, I think your career will be advanced, and also you can have more passion towards power and energy field. Thank you so much. Let's thank the two speakers, Kaya and Kathleen again. Thank you so much.
Thank you, Tina. Thank you,
Yeah.
everyone.
Thank you, Tina.
Yeah, if you are available, could you also turn on your video so we can have a quick screenshot? Okay. Okay. Thank you so much.
Thank you.
Thank you, everyone. We'll see you next week. Bye-bye.